functional group may present, then we need to do the confirmatory test. And the confirmatory test for them, carboxylic acid functional group, is esterification. So take the salt solution of that organic salt into the test tube, add a small quantity of sulfuric acid, then add ethyl alcohol. Then pour the contents into a water. A fruity odor, a strong fruity odor is observed. Then ester is the carboxylic acid functional group is confirmed. Suppose if no change is observed with action of sodium bicarbonate, then carboxylic acid functional group is absent. Then there we can mention that as no change is observed, alcohol may present. That means OH functional group may present. In the confirmatory test of ethyl alcohol, then take the given salt solution, add small quantity of concentrated sulfuric acid and add acetic acid. Then pour the contents into the water. There we may get a strong fruity odor. In such case, then alcohol functional group is confirmed. Suppose no change is observed with action of sodium bicarbonate and esterification test is negative, then we need to mention there that no change is observed on adding sodium bicarbonate. Carboxylic acid functional group is absent. Then esterification test is not observed, so alcoholic functional group is also absent. Then the next test is reaction with Schiff's reagent. Take the salt solution or the salt, whatever the thing which is given to you, take it into the test tube. Then, if ever it is solid, dissolve it and take that salt solution. Then add Schiff's reagent. If pink color is restored, then aldehyde functional group may present. If the pink color is not restored, then aldehydic functional group is absent. Then ketonic functional group may present. If pink color is restored, then there we need to mention that aldehydic functional group may present. Then we need to do the confirmatory test. So take the salt solution, add 2,4-dinitrophenyl hydrazine, that is also called 2,4-DNP. An orange red precipitate is formed. There we need to mention that orange red precipitate is formed. Then aldehyde functional group is confirmed. Then it may be acetaldehyde, benzaldehyde, maybe acetaldehyde or benzaldehyde. Then if ever in the ignition test a sooty flame is observed, then it is an aromatic benzaldehyde, aromatic aldehyde. If ever non-sooty flame is observed, then it is an aliphatic aldehyde, that is nothing but acetaldehyde. Suppose with the Schiff's reagent no change is observed, then aldehyde is absent. Then next is action of concentrated sulfuric acid. Means take the salt into the test tube or the salt solution into the salt solution to the test tube. Then add concentrated sulfuric acid. Charring means nothing but a burning may be observed immediately after adding concentrated sulfuric acid. Then glucose may present. That means a carbohydrate functional group may present. If ever the charring is observed after heating, then again carbohydrate functional group may present. If ever the charring is observed, we need to write carbohydrate functional group may present. Then we need to do the confirmatory test for carbohydrate. That is nothing but a Molish test. In the Molish test, take the given organic compound and add alpha naphthol. Then add concentrated sulfuric acid along the inner walls of the test tube. A violet ring is forwarded at the junction of the two layers, and after some time this violet ring will spread throughout. So we may get a violet solution. If a violet colored solution is forward in the Molish test, then carbohydrate is confirmed. Then next is, if the charring is not observed with the concentrated sulfuric acid and we did not got any response with Schiff's reagent and we did not got any response with sodium bicarbonate and in the esterification, then we need to do or we need to identify the phenolic functional group. So for that, take the given organic compound and then add a neutral ferric chloride solution. Violet color may be observed, violet color solution may be formed. Then phenol may present. And phenol has a pink color. By using the color also we can identify. So within this test also we get a violet color and a phenol may present. Then we need to do the confirmatory test for phenolic functional group. That is nothing but a Lieberman's test. In this Lieberman's test, take the given organic salt and then add a little small quantity of sulfuric acid and sodium nitrate crystals. Initially, a blue color solution will be formed. If ever we add excess of water to that, that blue color will be changed to red. If this change is observed, then phenolic functional group is confirmed. If no test is observed with sodium bicarbonate and the Schiff's reagent and this phenol identification test and also a carbohydrate identification test, and the only functional group that is left is that amine functional group and the compound may be aniline. So for that we need to do diazonium test. Take the given organic compound into a test tube and add the sodium nitrite and HCl, sodium nitrate crystals and HCl. A dark red colored substance may be solution may be formed. Then amine functional group may present. If ever we get that change, then we need to mention that amine functional group may present. Then we need to do the confirmatory test. Confirmatory test for amine functional group is isocyanate test. That is, take the given organic compound, add few drops, 3 to 4 drops of this chloroform, and then add alcoholic potassium hydroxide. And offense odor, that means foul smelling gases may be evolved. If the foul smelling gases are evolved, then amine functional group is confirmed. So with this identification of functional group in organic salt is also completed. Then we need to mention the report. And in the case of this organic salt functional group identification, for physical state, half mark, for ignition test, half mark, and for solubility, 1 mark, and identification of correct functional group, 1 mark, and confirmatory test, 1 mark. Overall, it is 4 marks. Then, the next fourth part is record. For record and viva, 5 marks will be awarded. So, overall, it is 30 marks. Now, see that chemistry practical seems to be a bit complicated, but actually it is a very, very easy thing. Because in the first year theory 60 marks, second year theory 60 marks, that is overall 120 marks are allotted for theory chemistry part and 30 marks are for practical chemistry part. So nearly 25% of the total theory is nothing but this practicals. And any student can do chemistry practicals thoroughly with just some 6 to 7 hours of preparation. That is qualitative analysis procedure, some 2 to 3 pages procedure, and volumetric analysis. For all the experiments of volumetric analysis, procedure is the same thing, and experiment is also same thing, but the accuracy in getting the result depends upon the time which you allot for doing that experiment. So do the experiment very, very slowly, you get accurate reading. Then the next part, that means the volumetric and the organic chemistry part. In the organic chemistry part, you need to concentrate a bit more. That is identification of the functional group. Different tests are there. Go through the procedure thoroughly, and also that confirmatory test procedure thoroughly, and do the practicals perfectly. We wish you all the very, very best. Now let us do the detection of carbohydrate functional group. So now I am taking a carbohydrate salt, and to this I am adding concentrated sulfuric acid. Yes. See, after adding this concentrated sulfuric acid to this organic compound, then we will observe just like the burning of that the substance that is taken into the test tube, and that substance present in it turns to black. So if the charring is observed, then carbohydrate functional group may present. So it may be a glucose or fructose. Then we need to do the confirmatory test for this. The confirmatory test for this carbohydrates is Molish test. So in the case of Molish test, I am taking the salt solution, that is the carbohydrate salt solution, and to this I am adding alpha naphthol. This is alpha naphthol. After adding alpha naphthol, then I am adding concentrated sulfuric acid along the inner walls of the test tube. a violet ring is formed at the junction of the two layers, and this violet ring will spread throughout, and after some time we will get a violet color solution. So this is nothing but a Molish test, and with this carbohydrate functional group is confirmed. In the case of detecting that aldehydic and ketonic functional group, the test is a reaction with Schiff's reagent. Here I am taking an acetaldehyde, and to this acetaldehyde I am adding this Schiff's reagent. This is the Schiff's reagent. Now, after adding this Schiff's reagent to this acetaldehyde, that pink color is restored. If the pink color is restored, then aldehyde functional group may present. It may be an acetaldehyde or it may be a benzaldehyde. If the pink color is not restored on adding Schiff's reagent to the given organic compound solution, then that compound is an acetone. Now we need to do the confirmatory test for aldehyde and ketonic functional groups. So in such case, again I am taking this acetaldehyde, and into this acetaldehyde I am adding 2,4-DNP, 2,4-dinitrophenylhydrazine. Then orange yellow precipitate is formed. If the orange yellow precipitate like this is formed, then aldehydic functional group or a ketonic functional group may present. If ever that given organic compound does not restore the pink color with the Schiff's reagent, then it may be a ketonic functional group. And the confirmatory test for both aldehydic and ketonic functional group is the 2,4-DNP test. So to the salt solution, that means to the given organic compound, we have added 2,4-DNP and we got an orange yellow precipitate. Then aldehyde and ketone functional groups are confirmed. In the identification of a phenol, I have taken the phenol compound, and to this I am adding a neutral ferric chloride. Now violet color solution is formed. So the formation of violet color indicates the presence of a phenolic functional group. Then we need to do the confirmatory test for this phenol. The confirmatory test for this phenol is Lieberman's test. In the Lieberman's test, we need to take that phenol, and to this few drops or very small quantity of concentrated sulfuric acid, is to be added. Then we need to add sodium nitrite crystals. This is sodium nitrite. Now I am adding the sodium nitrite crystals to this phenol. Now initially we get a dark blue colored solution. Now at the bottom you will find this dark blue colored solution, and if ever we add a large quantity of water to this, then it turns to this red color. So this is Lieberman's test, and phenol is confirmed. Now let us do this identification test for this primary amine functional group. The test is called a diazotization test. So in that case, I am taking aniline. This is the aniline. And to this aniline, I am adding a small quantity of concentrated HCl. After adding small quantity of concentrate HCl, then I am adding sodium nitrite crystals to this. Now a blood red colored solution is formed immediately after adding the sodium nitrite to that HCl and this aniline. This is called a diazotization test. If blood red colored solution is formed, then aniline may present, then we need to do the confirmatory test for that. And a confirmatory test for that, confirmatory test for aniline is isocyanate test. So in the case of isocyanate, we need to take that aniline and chloroform is to be added, and alcoholic potassium hydroxide is to be added to that. A foul smelling, very bad smelling isocyanide will be formed. So this is nothing but a confirmatory test for this aniline.